for D, you should have negative x plus 3 and x minus 3. Okay, so same idea, but this time we're looking at quartic functions, or functions to the fourth degree. So I've got, in this case, there's only one that's negative. It's to the fourth degree. So end behavior of a fourth degree polynomial, both arrows do the same thing, correct? So they're both going down. So this one with them going down has to be p of x. It's the only one that's negative. So this one right here has to be p of x. So then now I just have to determine f, g, and h. So f, g, and h are these three that are all rising. They look like wacky W's. So I can look right here to kind of try to help me figure out which one's which. Which one is going to be the one that goes down the furthest? Which one would that be? It has to go down the furthest, so it's stretched further down than anything else. Should be G. And then I have one that's really short and squatty. Which one would that be? H. That's the dashed one, the dotted one is h of x. And so then the one right in between those would be your f of x. All right, so each of these functions has x-intercepts at -3, -1, 1, and 3. They could each be factored like this: x plus 3, x plus 1, x minus 1, x minus 3, with some a value in front. So let's see, let's go over to p of x, because that's the first one we found. What's going to go in front as my a value for p of x? -1. And when you factor, you could always just put a negative, but it is technically a -1. All right, so now if I look at my other three, I have h of x, f of x, and g of x. Let's do g of x, because that was the next one we found. It's the really long one. It's taller and lower than the others. So what would go in front of g of x as your a value? 2. Because right here on my g of x function, there's a 2. Then h of x was the short squatty one. So what's going to go as my a value on h of x? 0.4. So it's a decimal less than 1, so it's a compression. So 0.4. And then for f of x, your a value is technically 1, because there's nothing in front of f of x. Is everybody okay so far? So now as we do this, it starts to make a little bit more sense why that last one at the end, when I multiplied it out, it was almost right, but it wasn't exactly right. Because I had the correct factors, I just didn't have that coefficient in the front yet. All right, so if they give me they can give you information to help you determine what that coefficient is, if they don't give you the coefficient. So find the polynomial function that passes through 0, 12 with x-intercepts at x equals 4 and x equals -6. So because they have 2 x-intercepts, they wrote them as factors. So that's what we were doing yesterday. If we know the x-intercepts, we can write them as factors. And then we set them up in our function. What I don't know is this a value, and that's what I'm trying to figure out. But they gave me a point. They gave me the ordered pair 0, 12. 0 is an x value, 12 is an f of x, or a y value. So what that means is I can go into this function that they gave me. I can plug in 0 for x. So they've started plugging in zeros for x. I can plug in 12 for y, and I can solve to find a. So they found a to be -12, -1/2, and then you can put that in the front, and then you can multiply it. So we're going to do number 7 together. It's cubic, so it has 3 x-intercepts. So they're right here. First part is to write them all as factors. So the x-intercept of -3, I'm going to write that as x plus 3. X-intercept of 4, I'm going to write that as x minus 4. And the x-intercept of 6, I'm going to write as x minus 6. Quick reminder about why they are what they are. If you look at this right here, x equals -3. I'm going to do this on a separate page real quick. So they wrote x equals -3 because it's an x-intercept. If I take that -3 and move it to the other side so that I no longer have an equal sign, when you move it to the other side, it becomes x plus 3 with no equal sign, correct? That's where this stuff is coming from. So x equals 4. If I move 4 to the other side, that would be x minus 4 with no equal sign. Now it's a factor. So we're rewriting them as factors. All right, I don't know my a value, so I'm just going to put an a in front. That equals f of x. Is everybody good that far? All right, now they gave me the ordered pair 5, 12. 12 is your y value, or your f of x value. So I'm going to plug 12 in for f of x. So 12 equals. I still don't know what a is, but I do know what x is. X is 5. So 5 plus 3, 5 minus 4, 5 minus 6. Now I'm just going to simplify. Eight, 1, and -1. So I get 12 equals -8a. I'm going to divide by -8. So I get -3/2. So a is -3/2. All right, but it asked me to find the whole polynomial function. So now I have to do a little bit of what we were doing yesterday and the day before. I need to multiply these out. This box is really small, I'm sorry. So x plus 3 times x minus 4. I'm going to do those two together first. That'd be x squared minus 4x plus 3x minus 12. Combine my like terms and I have x squared minus x minus 12. I still have to multiply that by x minus 6. X cubed minus x squared minus 12x minus 6x squared plus 6x plus 72. Combine like terms. So I have a x cubed minus 7x squared minus 6x plus 72. One more thing you have to do. So remember, now I know my a value over here is -3/2. So I am going to distribute -3/2 through. So I'm going to have f of x equals -3/2 x cubed minus 7x squared minus 6x plus 72. And I'm going to distribute that through. So you end up with -3/2 x cubed plus 21/2 x squared plus 9x plus 2 goes into 72, 36. minus, sorry, be negative 108. Yeah, okay.
Could we not just put it in front of the parentheses and try to do it?
I wish. No. That's okay. We'll do another one. It's all right. Don't panic. It'll be fine, I promise. Okay. Number 8. It's cubic. I got 3 x-intercepts. Write them as factors first. So go ahead and write them as factors. So as factors, they should be x plus 2, x minus 2, x minus 4. Is everybody good that far? All right, Papa A in the front, and that equals f of x. All right, they told me my f of x is 8, and my x value is 0. So I'm going to plug in. So 8 equals, I don't know a, 0 plus 2, 0 minus 2, 0 minus 4. Simplify that, you get 8 equals a, 2 times negative 2 times negative 4. So 8 equals 2 times negative 2 is negative 4. Negative 4 times negative 4 is positive 16a. Divide both sides by 16. And a equals 1/2. All right, we good so far on finding a? All right, so you're partway there. Now we have to multiply out our polynomials. Now, I have something nice on this one. I have x plus 2 and x minus 2. Those are called conjugates of each other. When you have the same two numbers with the opposite signs in the middle, they're called conjugates. And what's nice about them is you don't have to do FOIL. You don't have to do them all. When you have conjugates, you only have to F and L. That's it. Because the middle two are always going to cancel out. So that's a really good thing to recognize so that you can be more efficient. So I'm going to do those two first. So anytime you have conjugates, do them first because they're nice to do. All you have to do with conjugates is F and L. So first times first is x squared. Last times last is negative 4. That only works with conjugates. Everything else you have to distribute everything. And then I need to multiply that times x minus 4. Okay, is everybody with me? I don't want to keep going until I know everybody's good. All right, so now I'm multiplying out x squared times x, that's x cubed. X squared times negative 4 is negative 4x squared. Negative 4 times x is negative 4x. Negative 4 times negative 4 is plus 16. There are no like terms, so that's my polynomial without the coefficient in front. All right, so if I write it as f of x equals 1/2, because that's my a value, this is my multiplied out polynomial. I have one more thing to do, and that's distribute the 1/2 through the polynomial. All right, 1/2 times x cubed is 1/2 x cubed. Half of negative 4 is negative 2. Half of negative 4 is negative 2. Half of 16 is 8. Y'all good? You okay? Sort of? Yeah. That one wasn't as bad, right? Okay. This one won't be either. Okay, so find the quartic polynomial function with a double root. That may be the first time we've seen that terminology this year. What does it mean by double root? That's when it bounces. It's called a double root because it would be squared. So it counts double. So it's a double root, which means it bounces right there. So, and it's x equals 0. You could write it like this. You could write that as x plus 0 squared. You could write it like that because it happens at 0. But there's no reason to because x plus 0 is just x. So it's just x squared. So when I write that as a factor, I'm just going to write it as x squared. And then my other two are going to be x plus 3 and x minus 3.
Are we gonna put it in parentheses since we're gonna put the A in front?
We are. Or actually, you can just put the a with it if you wanted to. It won't hurt anything.
Okay.
We have conjugates again. So when we go to multiply out, we'll start with them. But let's solve for a first. They told me my f of x is negative 16. So negative 16 equals, I don't know a, but I do know x is 1 squared. 1 plus 3, 1 minus 3. Now we're just simplifying. Order of operations says I have to square the 1 first. 1 squared is 1, so that leaves me just a, 4, and negative 2. Four times negative 2 is negative 8a. Divide both sides by negative 8. And a equals 2. Now I know my a values, now we're going to go back over here and multiply out. So I'm going to use my conjugates because I just have to f and L with them, so that's x squared minus 9. You can distribute through the x squared. So that would be x to the 4th minus 9x squared. And then I can put my 2 on there and distribute that through. So I end up with f of x equals 2x to the 4th minus 18x squared.
Yeah, the other two were like that.
Yeah, that one wasn't bad at all. And that one we had extra room. All right. This one's quartic again. That means it's 4th degree. I have a double root at x equals 2. So that means when I write this one, x minus 2 is squared. Other x-intercepts, I have one at x plus 2 and one at 0. That's just an x. All right, so I'm going to plug in negative 10. A is what I'm solving for. I know x is 3. 3 minus 2 squared. 3 plus 2. I got a equals negative 2/3. So now we're going to go back up here and multiply these out. Now I do have conjugates, but I also have this one being squared. So this is up to you. I actually probably will do the conjugates first. So I'm going to do x minus 2 times x plus 2, because that's easy to do since you just f and L. F, L, x squared minus 4. Then that I have to multiply by another x minus 2. like terms to combine, but it's in, because of the way I multiplied, I have it in the wrong order, so I'm gonna rearrange the order. And at the same time, distribute through my final x, because remember I have an x out in front. It's supposed to be quartic when we're done, so that would be x to the fourth. That's gonna be negative 4x squared. X times negative 2x squared would be negative 2x cubed. X times 8 is positive 8x. And the last thing I have to do is distribute through the negative 2/3. So negative 2/3 x to the fourth plus 4/3 x cubed plus 8/3 x squared minus 16/3. Alright, are y'all okay? Sorta? This is really, I'm not even kidding, this semester, this might be one of the most, like, labor-intensive things we do for one problem, like the most steps for one single problem that we do all semester. It's not really hard, it's just a lot. You just have to do a lot.
So what I'm hearing is that there's more stuff to do this semester.
Yeah. Okay, so if you'll flip on the next page, it's the same thing. It's just this time they didn't tell us what the x-intercepts were. You have to find them yourself, but you can see them there. So if you identify the x-intercepts, this one's -1, this one is 3, this one is 5. Write them as factors, so that would be x plus 1, x minus 3, and x minus 5. It's cubic, I can tell by looking at it. It's 2 bumps, it should be cubic. I have 3 x-intercepts, so I should be good. Don't have to double anything, I don't have any bouncing. So I'm going to put an a in front, and this is f of x. And then they gave you the ordered pair 132. So this is exactly like what we were just doing a minute ago. You just have to start by getting your x-intercepts off the graph. So 32 equals, I don't know a, that's what I'm looking for. 1 plus 1, 1 minus 3. So I got a equals 2. Then you have to go in and multiply it out.